In section 2.7, we're looking at inverse functions. So our goals are going to be to determine an inverse function numerically by a table of values. Then we're going to use F inverse notation to represent the inverse function algebraically. And we're going to use the composition of inverses in both directions, f of f inverse of x and f inverse of f of x equals x, to show that a function and its inverse are truly inverses if their composition comes out to x in either direction. Then we'll talk about the domain and range of a function and its inverse. All right, so starting off in this situation, we're taking 16 credits to complete our program, but we're concerned about the amount of time that we need for studying. So the Academic Advising Center provides us with this table, and it tells us the number of credits and the amount of hours that you should put into studying per week. So notice the amount of study is a function because each of the inputs corresponds to just one output. So determine h of 14 and what it means. So we can tell right from the table, because there's an input 14 right here, that the output is going to be 26. And so this means that if you are taking the input is 14, so 14 credits, you should study for 26 hours per week. In addition to all your homework and other assignments, you should be studying for 26 hours per week for 14 credits. Okay, so using this information from the table, we're going to construct another table in which the input and output are reversed. So the number of hours of study becomes the input and the number of credits becomes the output. So we're going to swap this first ordered pair from 1222 to 2212. And then 2413, 2614, 2815, and so on. So using input-output values from the second table, determine whether the number of credits taken is a function of the number of hours of study. So if I look through this list, each of these inputs occurs only one time, so each input does go to just one output. So I have no repeated inputs. So this is going to be yes. Each input has a unique output. Not every table that you flip from left to right like this is going to be an inverse in the new form, because sometimes it can be a function, but there could be outputs that repeat even though the inputs don't. So if you flip it, it might not be a function, but in this instance, it is. Sorry, I'll scoot my page up right here. Yes, each input has a unique output, so even in reverse order, this is still a function. So we're going to call this new function C and determine C of 30. So 30 is an input in the new table. It gives me an output of 16. This function inputs the number of hours of study, outputs the number of credits. So we would say that if you can afford to, if you can, study for 30 hours in a week, you would be able to take 16 credits. Now, I want to note that the phrasing for the sentence down here and the sentence up here is different, even if I'm talking about the same ordered pair. If I was talking about that same ordered pair up here with 16 and 30, I would have said, if you take 16 credits, you should be studying for 30 hours, because here the 16 is telling me something about how much I should study. This is the reverse. It's saying, now I know that I can study for 30 hours. So how many credits would be appropriate for me to take? I could take 16. So the sentences do sound different based on what the independent variable is and what that tells you about the predicted output for that situation. What are the domain and range of h? Okay, so h was the top function up here. And this was the number of credits. We're going to go ahead and list these discretely since we're looking at the numeric function right here. So our domain for the h function was 12, 13, 14, etc., up through 18. And our range for the h function up at the top. So this had values like 22, 24, etc., up through 34. So those were the range values. Now on the top of the next page, they're going to ask me for the domain and range of the C function. So the domain for the C function is going to be the 22, 24, 34, etc. And the range for the C function is going to be the number of credits. It's going to be the 12, 13, 14, etc. up through 18. We're listing them discreetly because you can't take half a credit, so it's going to be whole numbers only. And while you can take under 12 credits is the lowest amount that's usually considered to be a full-time load for financial aid purposes. So that's why 12 is the lowest value listed in the table. And if we're just considering full-time loads, then this would be a reasonable range for full-time loads. All right, for C, how are the domain and range of the function h and the domain and range of the function c related? They are swapped, right? So if we have the function and its inverse, so for our h and for our c, if we look at our domain and range, the domain of h is the range of c, and vice versa. The domain of c is the range of h. So they're swapped. All right. Determine each of the following. H of 15. So that's from the original table. 15 is the number of credits. The output is going to be 28 hours of study. Then find C of 28. That's in the inverse function. So in the second table, 28 is the number of hours of study. 15 would be the number of credits. So we went in a little loop right here where we took, if we think about our H function, taking 15 to 28 this way, our C function does the reverse, takes 28 back to 15. So there's a little bit of a loop going on here if we use both the H function and the C function. H is going from credits to hours of study, and C is going back from hours of study to credits. All right, so I could have made these little arrows a little more loopy, but you get the idea. The H function and the C function are doing the left and the right transition in that loop. So now we're going to compose those two functions, C of H of 18. So I'm going to write down my information about 18 over here. In the H function, I would take 18 and I'll map 18 to 34. So the H function is going to map 18 credits to 34 hours of study. That's the innermost function. We do the innermost function first. Then the C function is going to map that 34 back over to 18. So our answer is going to be 18 here. When you do the function and its inverse, we're completing that loop. When we compose both the function and its inverse, we're going there and back again. So for any of these, if I take 34, I'll draw the map for this one again here. If I take 34 in the C function, that's going to map over to 18 in the C function. And then the H function would take 18 and map it back to 34. So we're going to end back where we started if we compose the function and its inverse. So again, C of H of 13. 13 with the H function is going to go to 24. And then in the C function, 24 is going to go back to 13. So I end up with 13. And lastly, h of c of 32. The c function first this time, 32 maps to 17. I'm just going to show the table for this because I'm looking at the table on my other page. I see 32 in the c function maps to 17, and then I see that 17 maps back to 32. Okay, so I am looking at the table as I map these out to get back to 32, but since it was on the other page, I wasn't flipping back and forth for every one of my maps, but I did use the table to see what these values were. All right, so the x represent the input, the number of credits taken for the function h. What is the result of the composition c of h of x? So when we compose the function and its inverse, we see that what went into the function is what ultimately came back out. It went there and back again. So wherever I started, if I use the function and its inverse, I'm going to end at that same place. So if I compose c of h of x, I'm going to go from x to a y value, then from that y value back to the x value. I'm going to land on x. And it doesn't matter which order I do this. If I did c of h of x or h of c of x, the same thing is going to happen. I'm going to go from my y value in the original function to the x and back again. So h of c of x, whatever x is what I'm going to come back to when I finish the composition. All right. So this is actually the way that you tell that two functions are inverses of each other. If you do the composition in either order and what you get as a result is the same thing you put in, then it proves that the two functions are inverses of each other. So are the functions h and c inverses? They are, yes, and that's just because h of c of x equals x and c of h of x equals x. So when we did the composition, we got the inside value x back out. In general, we write the inverse function of f as f inverse. We don't have to worry about naming them h and c and have all the different names for these functions. In general, we're going to call them f and f inverse. This little -1 in the corner of f inverse is not an exponent. It's just inverse notation. Notation is potentially confusing right here. It's not an exponent. It's just notation. It looks like one, but it's really not the same thing as it's not a denominator. Like the power is -1 on a number would put that 2 into the bottom. That does not happen for functions. That is not what this means. It just stands for inverse. And it's read f inverse. It's not read f to the -1. That would be incorrect. It's just read as f inverse. All right. So continuing down here, there is another example. This is our function. We're going to start. This is the example. This is our function down here, p. And again, it's listed numerically. So we're going to give the numeric inverse, p inverse. And each of these ordered pairs, input, output, will reverse in the inverse. So instead of 2, 4, I will have 4, 2. Instead of -5, 6, I'll have 6, -5. Instead of 0, 1, I'll have 1, 0. And instead of 7, 8, I'll have 8, 7. And that's the inverse relationship, p inverse. Flipping all the inputs and outputs. So p of 2, that's in the original function. In the original function, 2 goes to 4. So p of 2 is 4. Then p inverse of 4, that's in the inverse function. And in the inverse function, 4 goes to 2. So p inverse of 4 is 2. Now the composition, p inverse of 4 goes to 2. And then p of 2 goes to 4. 4. So I end up back at 4. So there is a middle transitionary step right here where I do the p inverse of 4, which is 2, and then I do p of 2, which is 4. However, if the functions are truly inverses, what I should expect to get for the answer is the same thing as the inside, because I'm going to go from 4 to 2 and then back from 2 to 4. Okay, so we're going to look at these one piece at a time. If I just do the p of 2 part, then I'll have to do p inverse of p of 2 is 4, and P inverse of 4 is 2, so we end back at 2. And again, no matter what you're putting in, since they are inverses of each other, P of P inverse of X is going to give us X back out, or vice versa, P inverse of P of X is going to give us X back out. All right, so there's a table here. Keep your eye on this table as we go into number 10. We're going to write the inverse for it on the other side. So I'm going to move this over here. The original table had 1, 2, 3, 4 in the inputs, so I'm going to put those in the outputs. And it had 2, 3, 5, 3, so those are going to become my new inputs. Does the table represent a function? The original does. So back over to the original. Each of these inputs, 1 only happens once it has 1 output. 2 only happens once it has 1 output. So this one is a function. Just so we're clear, the original is a function. If I get to the inverse, though, 2 only has 1 output. 3, though, has 2. 3 could have 2 as its output, or 3 could have 4 as its output. So it does not have a unique output. So this is not a function. And that's because the input 3 has more than one output. So as a result, the relationship in that first table, that Q function S equals Q of T, it just does not have an inverse, or rather its inverse is not a function. Okay. Could I have predicted that the function does not have an inverse? Yes. And I could have predicted that this function did not have an inverse if I had gone back and looked at it and said, oh, it does have repeating outputs. So it's a function, but there are some repeated outputs right here, right? That's okay in terms of the first one being a function, because it is a function. But if it has repeated outputs, its inverse will not be a function.